Right, and we're going to start using these equations, and I want you to think about them as ratios. So, molar mass, these are on your periodic table, and so what you can think about them as scientists have figured out how much a box weighs, and all you're doing is figuring out how much, in terms of mass, a ratio you have of that box. And same, you can work in mass or you can work in volume, and you can work out of that, Vm being this molar volume. And you can go, I can use my cheat sheet for that. So, for instance, 25 degrees and 100 kilopascals, which I've been using 101.3 because I want to get too into it. Anyway, 100 kilopascals and 25 degrees Celsius, that's 24.79 liters. That's the molar volume at that temperature and pressure. And you can start using that as ratios. So if I have 12 liters, I have pretty much half a mole, and so I've pretty much got 0.5 moles or half the particles. And so we're going to start using through examples how we can start combining balanced chemical equations and the mole concept to figure out basically how it can be like a cook and work in the right ratios in terms of masses and stuff like that. Right. So in our first scenario, we're looking at oxygen and how much is needed to fully combust 75 grams of ethanol. So hopefully you've done the balanced chemical equations and you know that ethanol, the ethanol's equations given to you, but you know that it reacts in a 1 to 3 to 2 to 3 ratio, which is all well and good. At first glance, I guess most people would go, if I've got 75 grams of ethanol, I would need 3 times that. I'd need 225 grams of oxygen, and it will give me that 2 times that. It'd probably give me 150 grams and 275, and it doesn't quite make sense in terms of grams. But that's the first kind of thing. People think they can relate particles with mass, which is not true. What you actually have to do is be in particle form, and we've now got the tools to calculate that. You go calculate how many particles of ethanol that you have. Well, if I have a box of ethanol in gas form, it would weigh close to, I think that's about 46 molar mass of that. And so if I have 75, I have 1.6 boxes, so to say, or about 40 liters if it was in gas form. And that's like 1.6 to 1 and 3/5 of a box. Okay. If that's the case, I would need 3 times the amount of oxygen from my balanced chemical equation to fully react with all that ethanol. So all I'm doing, okay, if that's how much ethanol, I need 3 times that amount. So it'd be 4.8, so close to 5 boxes of particles. And then you go determine the mass of oxygen. This is a rearrangement of this equation, right? 4.8 moles doesn't really make sense. I need to get back into a measurable and useful form. So I'm getting back into mass. And you go, all right, 4.8, this many boxes, each box weighs about 32. And so my actual answer is 156.29 and not 225. And this whole big blurb just talks about how questions are set up. Okay, so questions are set up so that you get given the mass and volume or density and concentration. They give you some indirect way to figure out the particles, the amount of particles you're working with. And then you figure out the particles you're working with to figure out how many particles you need or will make, or whatever, of another particle, another chemical species, and then you take that back into mass, volume, density, or concentration. Here's an example. How much gas is produced when you react 4.2 grams of sodium carbonate with 40 mils of 0.5 moles per liter? This is a concentration. It's actually molarity if you want to get technical. This says you have half a box in 1 liter. That's in liquid form as opposed to gas form when we're dealing this. We have half a box of gas in 1 liter of water. And that substance is phosphoric acid. Note that it says 25 degrees Celsius and 100, should probably say 100 kilopascals. I'm just making it confusing, at room temperature and pressure. And when I see that in a question, I know I'm going to be using this Vm or when I get moved on a bit, I can use this ideal gas equation in later videos. Either or, they both get to the same point. And you go, right, I do my balanced chemical equation. You almost always start with this. Chemistry, if you don't know what you're doing, just start with a balanced chemical equation. And it tells you it reacts with a 3 to 2 to 2 to 3 to 3 ratio. Okay, a bit of a mouthful. You go, right, out of my reactants, this is the ratio they all react with each other. How many particles am I working with? So you go, all right, sodium carbonate, I've got 4.2 grams, and a box of it weighs, I think that's close to 100 grams. And so you go, all right, that's roughly 0.04 or about 4% of a box. Great. Phosphoric acid, I used a different formula. This is concentration times volume. This is a rearrangement of this formula actually up here. Concentration equals the number of moles divided by volume, the number of particles you have per volume. It's very similar to density. And you know, my concentration, I have 0.5 moles per liter. So if I only have 40 mils or 0.04 liters, I would only have this many particles, 0.02. You'll see I have half the amount of particles as phosphate, so phosphoric acid. And here's, you're actually doing a pretty hard question here, because this is what's called a limiting reagent question, where you need to figure out which one of the reactants limits the reaction. And obviously they're not in the balanced chemical equation reacting in a 1 to 2 ratio. If that was the case, if it was 1 sodium carbonate, and sorry, that won't work because that was 2 sodium carbonates and 1 phosphoric acid, then this would fully react because it's a 2 to 1 ratio, right? And in this case, we've got a 3 to 2 ratio, and so people learn this in different ways. So one way to think about it is times the amount of particles by what's called their molar coefficient. So I've times phosphoric acid by 2, that gave me 0.04. I don't know why that's 6. 4. And I do 3 times 0.04 over here, and it's 0.12. And you go, all right, I don't have enough phosphoric acid. Not the way I learn. This is a lot of like the most common way I see as a teacher. The most common way the way I do it is I go, right, think about 1, and I'm going to divide it by 2 and times by 3. So for phosphoric acid, I have 0.02 moles, 2% of a mole. If I divide that by 2 and times it by 3, that gets me 0.03 mole. And that's how much of the sodium carbonate is needed to react with all of this. So if they react in a 2-3 ratio, I would need 0.03 of him. I have 0.04 of him. And so because that's less, I know phosphoric acid is my limiting reagent. It's the one that's going to fully react. He's not going to fully react. And so this is the one I want to focus on, because he's going to tell me how much do I make of that, and how much do I make of that, and how much do I make of that. And as a quick shortcut, if he fully reacts, because he's a 2 to 2 ratio, that's how much I'm going to produce in terms of that. I'm going to produce 2% of a mole of sodium phosphate. It'll be 0.03 and 0.03. This is how much is going to react. And if you really want to get technical, I'm going to have 0.01 left over of sodium carbonate. Okay. Right. And so, almost there. Using my phosphoric acid as my limiting reagent, I do my moles of carbon dioxide. I just kind of figured that out up here. It's 0.03. Remember, divide by 2 and times by 3. So pick your limiting reagent, divide by the 2 times by 3. That's what's happening here. Divide by 2 times by 3. 0.3, so I've got 3% of a box. And then I convert that to volume, because that's what the question asks, how much volume of gas I would produce. And so I'd go volume of carbon dioxide equals the number of particles I have. I have a third of a